one-to-one functions. We have established that we can identify functions with a vertical line test. So remember, a function is a subset of relations, and they satisfy the vertical line test because each x value must give rise to a unique y value. Functions, though, come in two types. We have one-to-one functions, and we have many-to-one functions. A one-to-one function is a function in which no two ordered pairs have the same y-coordinate. Note the similarity with distinguishing functions. A function has no ordered pairs with the same x-coordinate. A one-to-one function has no ordered pairs with the same y-coordinate. Therefore, since we can tell those relations that are functions using a vertical line test, we can distinguish a one-to-one function from a many-to-one function using a horizontal line test. And the criteria for the test is the same as it was for the vertical line test when distinguishing functions. If any horizontal line cuts the graph at most once, the function is one-to-one. So let's look at an example. So we have this line here, which we've met before, and let's bring in the green line to test. This time it's a horizontal line. And at the moment it would be cutting the line once because the arrows on the end indicate that this line goes off infinitely in both directions. So if we sweep the green line up, we can see it always cuts once. There's never a time it's going to cut twice. Therefore, this is a one-to-one function. Now let's consider this graph here. And let's bring in our testing line. If we sweep this up the graph, at the moment, notice it's okay. It's not cutting the graph at all. So it's passing the test at this moment, but it has to be any horizontal line. So we need to sweep the line up the graph. And if we do that, we can see at these points here, it's cutting the graph twice. So this is a function because it would pass a vertical line test, but it's not a one-to-one function. So it's a many-to-one function. The green line cuts the curve in two places in certain positions, as we just noted. So this is a many-to-one function. Now let's consider this set of ordered pairs. This set just here. And we'll bring in our testing line. And we can see at the moment that testing line is not cutting the graph at all. Let's see what happens as we sweep down. It's okay at the beginning, but we get to this point here, and it cuts 2 points. This, therefore, is also a many-to-one function. Here we have another set of ordered pairs. And it gives rise to this graph here. If we test this one, as we sweep the line through, it only cuts once or not at all. And therefore this one is an example of a one-to-one function.